So, a drought is a period of drier than normal condition. A drought can last for days, months, or years. Drought often have large impact on ecosystem and agriculture of effective area and cause harm to the local economy. A region's economy, agriculture, natural habitat, and hydrological balance can be severely impacted by severe drought. Many drought indicators claims to able to gauge the severity of drought. However, many of them omit important information. A fog-based paradigm for drought prediction is being presented in this paper, enabled by Internet of Things. In the design data, the data is being compressed at the fog level using single vector decomposition. The adaptive neuro freezy inference system mechanism is being used to assess the severity of the individual drought occurrence, while the halt winter technique is being used to forecast future drought conditions. With the use of Internet of Things sensors, automated system can gather real-time data on all the cause of drought by analyzing massive volumes of data, which is made possible by cloud computing and big data. We can better assess the severity of drought. There are many drought indices, each with its own self of benefit and drawbacks due to the unique combination of input factor used to calculate the drought severity. The integration of fog, cloud, IoT could significantly benefit drought assessment and modeling. In the many researchers have assessed the effectiveness of various drought indexes, such as Mishra and Son published a comprehensive assessment of drought indicators highlighting various shortcomings and comparing several drought indexes. Zhang analyzes the severity and the frequency of drought in Korea's 73 weather stations, comparing the standard precipitation index. Data mining approaches has been used in many drought prediction and forecasting studies. Zhou proposed using Apache Hadoop to analyze data from the worldwide vegetation drought monitors. The objective of my research is to monitor the performance of IoT sensors to track various drought factors. Cloud based predictive scarcity analysis is being used artificial intelligence based technique. Enhance bandwidth utilization by implementing a data reduction technique that is known as SVM. Forecasting intensity of drought is estimated for different temporal instances. In this, the real-time monitoring is also used by IoT sensor to track various drought factors. So this is my proposed model. In this, we have the four layers. The number one layer is known as data sensing layer. The second one is fog layer. The third one is cloud layer, and the fourth one is information sharing and communication layer. In the first layer, the data is being collected from various sources that is being associated by the drought. After that, SVD, data reduction using SVD is being used in the fog layer and it is being transmitted to the cloud layer. In this drought severity prediction is being used, and after that, the information sharing is being there. This is the proposed framework of the proposed model that is being given by me. In this, two algorithms are being used. The number one algorithm is basically used for reduction using SVD, and the second one is being used for forecasting drought severity. In the drought severity, we will initialize the level, the trend, and the seasonal components. After the initialization, we will update the value of the level, trend, and seasonal components. After that, determine the value of the forecast level. And after that, there is the future drought severity, in which Hall's approach is being used. So these are the results of the proposed model. In this, ANFIS machine learning model is being implemented in the Python platform. Benchmark model, including K-neighbor and conventional artificial neural network and SVMs are being used for the comparison purposes. To evaluate the accuracy and suggested model, various statistical metrics, including sensitivity, specificity, and accuracy F measures are being used. Moreover, the outcomes are being contrasted with the state of the art AI mechanism for determining the self system enhancement. So the table is being shown in this the results. In this, the forecasting accuracy analysis in is there. In this MAE, MSC, RMSC of first month, 6 months, and 1 year is being presented in this. So at last, I would conclude that in my research, a cloud centric layer architecture is being developed for forecasting the drought situation. In this, the system efficiency monitors and analyze the drought condition by deploying network sensor in statistical location to collect the primary data contributing to a drought. The unique feature is being used, and SVD is being deployed at the fog layer, which enables the transmission of only essential data to the cloud. After that, SVD, it passes to another layer. At the sub layer, the cloud model responsible for the drought prediction and FIS classifier is basically used for estimating the drought intensity category. The halt winter method is also being used for predicting the future drought occurrence. Comparing the result with the other drought indicators, the cloud layer based on Amazon E32 achieve impressive accuracy. The accuracy is more in Amazon EC2. So, result provision valuable outcome for the relevant authority and department to make real-time decision. By this paradigm, we are able to provide good results and monitor the scarcity of drought in an area. Thank you.